Hello everyone, I welcome you all to one more session on numbers. So this is the sixth video in the series, number 6. So in this particular video, we shall be taking up the concepts of division rule particularly, and then we will be looking at some properties of remainders also, useful properties of remainders. This is not remainders video, so to say, alright. So here the minimal aspects of remainders, small properties of remainders is what we shall be covering, and we will be backing it up with one or two small examples. Let us get started with the session. So as I told you, today's session is going to be pretty brief. So if you want a more detailed discussion on it, I would suggest you please subscribe to the channel. One thing, alright, because we upload some questions also, alright, questions videos also. And second thing is, please do visit your nearest time center and get enrolled in a course of your convenience, alright, which suits you, alright, morning, evening, whatever, alright, weekend, so that over there in that particular course you would be able to discuss these topics at much greater depth. Let us get started. So we are talking about division rule today. So when we divide any number, let us say 33, just a minute. So when we divide any number, let us say 33 by 8. So the way in which we carry out the division is, we say 8 will go 4 times 32 and we will be left with a remainder of 1. So here there are 4 terms essentially that we will be interested in. One of the terms is the number that is getting divided, which we call as the dividend. The second number is the number that is dividing, which we call as the divisor. Then we have the quotient here and the remainder. We are aware of these 4 terms already. Now these 4 terms are always connected by an equation, right? They are always connected by equation, which is called as division rule, which states dividend in any division, for example here 33 will be equal to divisor into quotient. So in this case it will be 8 into 4 plus the remainder. So this is what is the division rule, and you can always verify it. For example, here also it is going to be plus 1. So 33 is 8 into 4, 32 plus 1 is absolutely alright. So here we have 4 variables, 4 terms which are connected by this equation. Now here there are some properties that we have for say quotient, for example say remainders. What are the properties? Let us try to study them at some depth, and then we will try to see how do we make use of these properties in this session also and future sessions also. So let us start with the properties. Property number 1, point number 1 is, when we talk about quotient and the remainder, they must always be in our general division, because we deal with natural numbers and all, they must always be whole numbers. That means quotient or remainder may be 0. So let us try to study cases where they will be 0. So for example, if you notice that dividend is less than the divisor. For example, let us say you are trying to divide 13 by 21. So clearly the division is not possible, right? So what do we say here? 21 will go how many times? It will go 0 times. So 21 into 0 is 0 and remainder will be 13. So it is a very special case. If your divisor is more than the dividend, then in that case the quotient will be 0 and the remainder will be equal to the dividend. But generally speaking, this will not be the case. You will always have the dividend being the bigger variable, right? So dividend will be bigger. So in such cases, Q and R will be natural numbers, right? Remainder may be 0 still, because exact divisibility might happen. For example, let us say you are trying to divide 24 by 4. So 4 will go 6 times, 0. So remainder may be 0 still, but quotient will be definitely greater than 0 if your dividend is more than the divisor. Now observe this. Remainder in any division must be less than the divisor, we say. Now, why is it so? Observe, if I try to divide 27 by 6, say. So, 27 by 6, what do we get? We'll say 4 times and 24, etc. Let's say I make a mistake here. I say it's not 4 times but 3 times. So, 6 into 3 is 18. 27 minus 18 is 9. I say this is my remainder. 9 is my remainder. Is it correct division process? Is it mathematically right? So, the answer is of course not. Now, why is it wrong? Because the remainder must always be less than, not even equal to, it must be less than the divisor. So, that means here in this case, if your divisor is 6, your remainder can never be more than or equal to 6. Right now, you're getting 9, not possible. So, what's the mistake that we have committed? We have made a mistake here in counting the total number of complete 6s that we get in 27. So, what do we do in that case? Let me just write it down. Remainder should be less than divisor. If not, we redivide the remainder obtained. What do we do here? Whatever is the remainder that we have here, we are going to redivide it. So, that means again we are going to divide it by 6. So, 9 divided by 6, it will go one time. 6 into 1 is 6. Then I will get the remainder of 3, which will be acceptable now. This is going to be acceptable now. Because it's less than the divisor, it's okay. So, the point is, remainder must be less than the divisor. If it is not, then you redivide the remainder. Sometimes if you want to, we can represent, here we have said they should belong to whole numbers. Okay. Remainder and quotient both should belong to whole numbers. But to have some convenience, we can sometimes represent remainder as negative remainders also. Let me tell you why, how and why we do that. I'll just show it to you here. Observe, if I ask you 27 divided by 6, what's the remainder? The remainder will be 3. So, can I write, or let's do one thing, let's divide by 4. Let's divide by 4 so that I can differentiate between positive and negative remainders. Remainder is 3, right? Sorry, 3. So, can I write dividend is equal to divisor into quotient plus remainder. But the same, can we also write 27 as divisor into quotient plus remainder. 28 plus minus 1, which is 28 minus 1, will give you 27 again. So, the same 27 can be written as remainder of plus 3 or remainder of minus 1 also. And again, please remember, this is never, we are not going to ever answer this as minus 1, the remainder. We are always going to answer the remainder as plus 3 only, because I wrote remainder should be whole number. It cannot be negative. This is for our convenience that we are creating it. Okay. So, here if we want to write remainder plus 3 as negative, we write it as minus 1. So, sometimes for our convenience, we can do that. Now, why are we bringing in this convenience and all? You will understand that in this class to a certain extent, and again in our future classes also. Now, how do we convert negative remainder to positive remainder or vice versa? The process is, if you have positive remainder and you wish to convert this into negative remainder, the process is, from here to here, you subtract the divisor, whereas from here to here, negative to positive, you add the divisor. As an example, here you please notice, the positive remainder was 3 and negative was minus 1. Now, how do I convert positive to negative? So, for positive to negative, you need to subtract the divisor, we said. So, what's the divisor here? 4. You subtract 4 here, plus 3 minus 4 will give you minus 1 as the negative corresponding remainder. So, this way, if you want to, for your convenience, you can always convert any positive remainder in division to the corresponding negative remainder or vice versa. Now, why do we do it? Why are we even talking about this property? What is the use of it? Let's try to understand that with the help of a small problem. Notice, find the remainder when 13 to the power 87 is divided by 14. So we have to find the remainder for this large number 13 power 87. So how do we figure that out based on what we have discussed so far? So here please note 13 power 87, what's the value I don't know, but can I say the following? Can I say the following, that by observation remainder when you divide 13 by 14, the remainder is 13. Now that's the positive remainder. What's going to be negative remainder? We know the process of converting, right? 13 minus 14 will give you minus 1. Now we have one very useful property. I'll just write down the property also somewhere, you can also note it down. This is going to come after this, alright. The property is, if remainder when n is divided by d is r, then point number 1, remainder when k into n is divided by d will be equal to k into r. So that means if the number is multiplied by k, remainder is also going to be multiplied by k. K should be a natural number, it cannot be a fraction, of course. Natural number because we deal with natural numbers only, alright. Remainder when n to the power k is divided by d, the remainder should be r to the power k. Again k should be a natural number, it cannot be a fraction. So these are two more points that I want to share. Now observe here. Now the positive remainder is 13, okay, but the negative remainder looks more appealing for us. Why? Because if I ask you what is 13 cube, you will take some time to calculate it. But if I ask you what is minus 1 cube, you already answer it as minus 1. Now consider this worst case. If I ask you what is 13 power 10, you won't be able to answer it immediately. You will use calculators, you will take few minutes to get to the answer. Whereas minus 1 to the power 10 is an immediate answer, right? It's plus 1. Because minus 1 to the power anything will be either plus 1 or minus 1. That's it. That's the convenience that you get if you convert this positive remainder to negative remainder. Now making use of the second point here, can I say the question was power 87. So remainder when 13 power 87 is divided by 14, can I say my answer should be this or this? This is very difficult to calculate, so I won't even look at that. So minus 1 power 87, power is odd, it's going to be minus 1. But we never leave our answer as negative. What do? We convert it. How do we convert to positive? You add the divisor. So thus my answer out here is going to be 13 is what we can say. I hope we are clear with this. So this is the use that we have out of the basic property that we have discussed for remainders. So negative remainder to positive remainder. Now one more thing. Sometimes you have to break down a bigger number into smaller components so that the ease of calculating the remainders improves. So there is a property pertaining to that also. If you notice, if n is equal to a bigger number n is written as n1 plus n2 plus n3. It could be more than 3 numbers also. It could be perhaps 5 or 10 numbers also. I am writing down for 3. Then the corresponding remainder in case of n. So remainder when n is divided by d, let's say it is r. Remainder when n1 is divided by d, let's say it is r1. Similarly, remainder when n3 is divided by d, let us say it is r3. Then we may say if n is equal to n1 plus n2 plus n3, then r, the corresponding remainder here, will be equal to corresponding remainder in the first case plus second case plus third case. You may say this. Okay, these are the notations. What is r, r1, r2, r3? That is what they are. So if n is equal to n1 plus n2 plus n3, then r will be equal to r1 plus r2 plus r3 is the point. Let me explain this with a small example. Observe this. Can we write 38 is nothing but 31 plus 7? Right, makes sense. Now let's say if you divide both sides by probably 3, let's divide by 3. So 38 by 3, what's the remainder? 38 by 3, manually if you do it, the remainder is 2. Now 31 by 3, what's the remainder? It's 1. 7 by 3, what's the remainder? It's 1. And as you can see here, the corresponding remainder in the first case, r is equal to r1 plus r2. So r is equal to r1 plus r2 is absolutely alright. So we can just accept this rule. Now there is a similar rule that we have for, I'll write it down directly now. Then R will be equal to, and similarly, if I have n is equal to n1 into n2 into n3, R will be equal to R1 into R2 into R3. So these are some basic properties that we have for remainder, and of course there will be problems associated with it, right? For problems and all, as I said, you please keep following our channel. We will be giving you CAT level questions, right, based on various concepts, not necessarily on this. Of course, this will also be covered in one of the or few of the videos, but it's not in order. It's not like if you're doing numbers here, there will be numbers based questions. It's all mixed there. So please keep following that too. So with that, we have reached the end of the session for today. All right. So today I'll just end with the last property that we have discussed. Please do go through the video, make notes, right, and please practice the problems, right. And if you want a more detailed discussion, as I said some time back, please do visit our TIME centers. On that note, let me end the session here. Thank you and all the very best.